Now let's look at a problem that involves integration by parts and substitution, where the substitution is a little more involved. So in this case, we're integrating e to the 4 times the square root of x. So what we're going to do is we're going to do a u substitution, and we're going to let u equal 4 times the square root of x, which we can think of as 4 times x to the 1/2 power. Then du will equal 2 times x to the minus 1/2 dx. Or we can think of that as 2 over the square root of x dx. So now let's look at what happens if we try to make the substitution. We'll have e to the u, and what we have remaining is dx. But if we go over here and we solve for dx, we see that dx equals the square root of x over 2 du. And we need to express dx only in terms of u and du without x involved. So what can we do? Well, if we look up here, we see that the square root of x can be written as u over 4. So we can replace the square root of x here with u over 4, u over 4 over 2 du, which is the same as u over 8 du. So now we're ready to replace dx with u over 8 du. And if we pull this factor of 1/8 out front, we'll have 1/8 times the integral of u times e to the u du. And now we're ready to use integration by parts. So let's do our shortcut method here and draw the table. And here we'll put the functions we're taking the derivative of. Here we'll put the functions that we're integrating. We have an algebraic function and an exponential function. So we'll write the algebraic function here and the exponential function here. Taking the derivative of u with respect to u gives us 1. Integrating e to the u gives us e to the u. And if we repeat this, now taking the derivative of 1, we have 0, and taking the derivative, and integrating e to the u, we have e to the u. So now our integral becomes 1/8 times, and we take the product of these two entries, u, e to the u, and now we alternate signs and take negative the product of these two entries, e to the u, so minus e to the u, plus a constant of integration. And our last step is to do a substitution in terms of the original variable. And recall we had set u equal to 4 times the square root of x. So everywhere we have u here, we simply replace it with 4 times the square root of x. Now let's look at the same problem, only as a definite integral, where we have the limits from 1 to 4. Okay, so recall what we had figured out was that the integral of e to the 4 times the square root of x dx was equal to 1/8 times 4 times the square root of x e to the 4 times the square root of x minus e to the 4 times the square root of x plus a constant of integration. So now we're going to use this result, and we'll have 1/8 times 4 times the square root of x e to the 4 square root of x minus e to the 4 square root of x, and all of this evaluated between 1 and 4. So using the fundamental theorem of calculus, we'll put in the 4 into both terms. So we'll have 4 square root of 4 e to the 4 square root of 4 minus e 4 to the square root of 4, putting 4 into both terms there. And then minus from our fundamental theorem of calculus, and then we'll put 1 into both terms for x. So 4 times the square root of 1, e to the 4 square root of 1 minus e to the 4 square root of 1. And now let's just clean this up a little bit, knowing that the square root of 4 is 2 and the square root of 1 is just 1. This will become 1/8 times 4 times 2, which is 8, e to the 8th minus e to the 8th minus, and here we'll have 4e to the 4th, And distributing the minus sign and simplifying, we'll have plus e to the fourth. And if we want to do another simplification, we can combine these two terms. We'll have 1/8 times 7e to the 8th. And then we can combine these two terms, and we'll have minus 3e to the fourth.